Perfect. Okay. So this week we're talking about, we're going to do a little bit on relations, although probably just skimming over it. And we're going to do some work on graphs. I think that's like the big thing we're going to focus on. So in terms of relations, relations are just generalizations of functions, right? I think we talked about that. They're ordered pairs. It's a subset of ordered pairs, tuples. There's a few special kinds of relations. A reflexive relation means that for all A with itself is in the relation, or A is related to itself. Symmetric means that if AB is in the relation, then BA is in the relation. Antisymmetric means that, symmetric, yeah, means that, so if A, B is in R, implies that BA is in R, then A equals B. So the idea with antisymmetric is that if you have two things and you're able to swap them, the only case you could do that is if they're actually the same thing, right? Which obviously you can swap. If it's like 3, 3, you can obviously swap those because 3 is just equal to 3, right? The last one is transitive, which means that if A and B are in the relation and B and C are in the relation, then A and C are in the relation. Does that make sense? Cool. We got that. That's a bit on relations. Now we'll go on to graphs. I have a big list of terminology because that's like the big thing with graph theory is terms, right? You want to make sure that your terms are all good. So, does anyone know what a graph is? A graph it's just a tuple of two sets, V and E. V is vertices, E are the edges between them. So it's a list of vertices, of points, and how they're connected to each other. So a graph represents connections. It's like a network. So let's say that we have some vertex in V. Does anyone know what the notation N of V means? No? It's the neighbors of V. So if you have some graph, say this is V, the neighbors of V are going to be this one and this one, right? All the things that are directly connected to V. So N of V is a set. In this case, if this was like X, Y, Z, N of V would be X, Z. So just the two things that are directly connected to V. What else do we have? Let's see. What's a loop? Does anyone know what a loop is? Yep.
Something that goes back to itself.
Exactly, right? So if Y had a loop, it would look something like that, right? So it would have like a connected to itself kind of thing, or adjacent to itself.
Can a loop also be the connection of the vertices going back into V? So it goes X, Y, Z, then V again? Can that
No.
be considered a loop, or is it only when it's connected to itself?
Only when it's connected to itself. Yeah. That's called a cycle, when it does like that thing. Yeah, there's a lot of words and they all sound the same, right? Okay. What's a multiple edge? Yep.
It's like when there's one
Yep.
There was another one that X and,
Yeah, it was like two
yeah.
lines going between two vertices, right? It's a multiple edge. Cool. What else do we have? What's a simple graph?
When there isn't none of that or loops.
Yeah, no multiple edges, no loops. Simple. What's a regular graph? Sounds like it should be the same thing, right? Because they're both just words, but a regular graph, yeah.
Isn't it when it has like multi-edges but no loops?
Nope, not quite. So a regular graph just means that every vertex has the same number of edges going outward. This is not regular. For an example, this graph is regular. Each vertex has 4 things coming out of it. There's other examples, right? So I could, I guess, do like, I don't know, get rid of some of them. It's probably a nice way to do this that would, still having a problem, aren't I? Well, yeah, let's say that this, just to make this, my life a little easier, this is also a regular graph if you do, this with 2 loops. It's a really ugly regular graph, but everything has 3 things. I think, is that right? Oh no, I need to get rid of one, I think. Yeah. Yeah.
So they all need to be of the same degree?
Yeah. Regular means that they're all the same degree. Exactly. What's a subgraph?
So a smaller version of an already completed graph?
Yeah, so you just take some subset of it, right? So if I took this, 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 and this, I could make a subgraph out of it, and it would look like, let's see, this, 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 this. It's a terrible edge, but whatever. This looks like it would be about that, right? Square with a line through it. Okay, we got that. What does it mean for a graph to be connected?
Can you like draw the whole thing without like taking away?
That's a good thought. It's not that. Yeah.
Is it like when you can access like all vertices at any point, so you can like go from 1 to 4 to maybe 3,
Yeah.
and then go back to 1, and you can go back to 4, and whatever.
Yeah,
so
so
you
you
can
can-
access any vertices.
You can reach any vertex you want.
Yeah, so you wouldn't get stuck in that loop that over there.
Yeah,
basically.
exactly. You'd never get stuck, and you'd never, like for example, this is a graph, but it's not connected, it's disconnected. If I draw this,
And what is it called again?
disconnected.
No, is it called a connected graph? Is that what it's called?
Yeah, like this would not be connected,
Okay.
right? But this is connected. We call these 2 pieces components. 2 components of a disconnected graph. Got that. The degree is the number of edges coming in, right? So in this case, this vertex has degree 2 because it has 2 things coming into it. Am I missing anything? Regular, we did. What's a clique or a complete graph? Or KN? Let's say K5.
Oh, there's 5 different, what's it called? Vertices?
Yep. What about the edges?
It would be.
Everything's connected to everything else.
Everything's connected to everything. Yeah, so this is called a complete graph or a clique, or there's a couple different words for it, but yeah. A cycle is like what we were talking about earlier. That kind of thing is a cycle. This is C4. A path looks like this, where they're all sort of in a line. This is P4. And then I'll do a star, something like this. This is S3, S3. Does that make sense? Cool. Any questions? I will stop the recording here.